Hi YouTube, I'm Brittany, and today I'm going to be talking about whether the trait section of Ancestry.com is legit or whether it's bullshit. If that sounds interesting to you, stick around and we'll get into it. So a few months back, I heard about how some products like Ancestry and 23andMe were starting to expand their initial offerings beyond just like genealogy testing and into things like trait assessment. These included traits like eye color and hair color, but also expanded into things like whether or not you might be an introvert based on your genes. As someone that works in biology research, this rang a few alarm bells in my head. Not that it's necessarily harmful to do things like this for fun, but it's different to claim something's based in science when it's not. And that's what I want to find out, if this is actually based in science. And before we get into it, I think it's probably helpful for me to give you a little bit of a rundown on my specific background so you can decide if I'm someone worth listening to on this. I currently work in biology research, managing a research lab specifically. I have helped in research related to infectious disease, cancer, and autoimmune disease. I don't have a PhD, to be clear, but I do have both bachelor's and master's degrees in biology, and my master's has a forensic DNA and serology focus. So overall, I feel pretty equipped to handle this. I don't do this type of genetic research in my day-to-day, but DNA and genes are very much a part of my life to think about all the time now. Assuming you're still on board with listening to me for however long this takes, I'll give you a quick rundown of what exactly I plan to do with this video, and then we'll hop into it. In the first section, after this little intro, I'm going to go into my initial impressions. I'm going to hop over to the website, check out the traits section, and see what I'm thinking. I'll come back in section 2 and have done some research on exactly how they're making their claims, what they're basing their claims off in, and just kind of give you the rundown on the claimed science. In section 3, I kind of want to zoom out and talk about the ethics of direct-to-consumer genetic testing. This might be brief, even though the topic is huge, just to be like reasonable with time on this video, but I could definitely probably expand this into its own video at a later point. In section 4, I'm going to hit a quick consumer review, what it might be like from a customer perspective if you're not doing intense research. So we'll hit that as well. And then finally, I'll close out the video with my final thoughts and conclusions and just try to wrap it up in like a semi-coherent way. No promises it'll be fully coherent, but that is the goal. Hopefully you're still interested and ready to jump into it. I'll catch you in the initial impressions. So, Ancestry.com. When I did this originally, there was only the DNA story and I didn't have the traits, but I saw that thing where they're like assessing your traits and like what kind of human you are. So we're gonna look at that, see first glance what it looks like, if it seems immediately like bullshit or if it feels like potentially real, see how complimentary it is, which will determine my opinion about it, and then I will do some research and see how much science there is on this stuff. So let's go. Explore your traits. Science. Immediately no. Immediately, absolutely not. Okay, so there's behavioral and personality traits, nutrients, fitness, sensory, and appearance. Okay, off the cuff, I know that there are things that can impact nutrients, physical appearance, obviously, and maybe fitness from a science perspective. Like there are genes that are well studied that influence those things. I don't think that's true of behavioral traits, but we'll look at it. Immediately seems wrong. Introvert to extrovert. I am not an extrovert at all, so that's a miss immediately. And risk taking, would not say avoids taking risk feels right, but let's look at it. Okay, more extroverted. How? Okay, here's how they're defining it. Introverts tend to focus more on the inner world of ideas and images, and extroverts tend to focus more on the outer world of people and things. Sure. Research suggests extroverts may be more motivated by rewards than introverts are, potentially due to a difference in sensitivity to dopamine. Would like to read more, but sure. Okay. And so genetic factors, they analyzed the DNA of a bunch of people that answered a survey question about introversion and extroversion. They were placed into two groups and then compared their DNA to identify a bunch of markers. I would need to see the test they gave them. Like, did they define it? Did they just say, are you an introvert or an extrovert? Or like, what? Weird. How they answered. Do you prefer to do things alone? Introverts are most of the time. Yeah. Do you enjoy social gatherings? Sure. Are you a morning or night person? That feels unrelated, but sure. Do you take initiative when making new friends? Do you prefer loud parties over quiet ones? Ugh. Absolutely not. It's wine nights only. Okay. I'm not going to click at all of these because that's too much to do while recording, but I will also click on morning or night. This one feels like maybe right. I wake up really early every day. I'm like between 5 and 6 a.m. wake up every day, and I go to bed pretty early. But it seems it's more like I forced myself to do that, and now that's just my habit and not necessarily that that's like super intuitive. I'm like a pretty grouchy morning person. I'm not like a wake up and be chipper. I'm like a wake up and drink coffee for an hour. Okay. Okay. It's saying that there's a large environmental impact. That seems helpful. Okay, this is good. Note, social jet lag. Most people stay up too late on weekends compared to when they normally fall asleep. Can impact overall sleep health. Yes. Most creative during your non-peak hours. Interesting. Why did they mention the DMV twice? Weird. Weird choices. Okay, it was another survey result. I don't know. Surveys, like, from an immediate, I'm not researching, I'm not, like, looking at the papers they're citing. Surveys are a little tricky. There's a lot of ways to accidentally get people to answer in particular. Like, you have to be really careful with how you craft surveys to get them to work effectively, or people will answer, like, you kind of bias the answer unintentionally a lot when you do surveys. So I'm a little hesitant to say that that's, like, for sure, but maybe I would have to look at the surveys. See who published the research and such. Okay, risk-taking. This is another one that I feel like is wrong. Suggests you have a stronger tendency to avoiding risk. My genetics suggest that you're more likely to be risk-averse than 80% of the population. This is hilarious. I guess, like, I'm curious how they define risk, but I feel like when I talk to people, they usually think I am, like, the opposite of that. Like, I'm more risk-inclined. For one, I've, like, bungee jumped and skydived, and I want to go wing walking, which is, like, a pretty risky thing to do, I guess. But also, just in life, I don't really tend to be super, like, safety oriented when I'm making life decisions. Okay. It's doing another, like, there's a lot of environmental impacts. Okay. Do you bravely ask a stranger? What is this? Okay. Risky business when nature calls, but the toilet paper dispenser does you dirty. Do you bravely ask a stranger if they can spare a square? Or do you wait until they leave and shimmy over to help yourself? Sometimes but not all risks are equally genetic. For example, financial risk is about 29% genetic and safety is about 55%. Studies have yet to be performed on shimmying in a public restroom. That is weird. That is a weird thing to talk about on this site. Make new friends, but keep the bold. From supporting the New York Knicks to eating spaghetti while wearing white, life is full of risks, and people take more of them when encouraged by peers. If you seek out a friend who speaks of politics. Yeah, okay. Okay. They found a lot of DNA markers, over 23,000 connected to risk-taking. So how did they use those? Ancestry question. Okay, they had a survey question that helped their research. but this is based on DNA, not your survey. The data and the math uses a predictive model. I know predictive models, but okay, by comparing your DNA, do they use all of the genes? Like, do they use all 23,000 plus, or do they do some? Okay. Weird. They're not okay, they're not telling me how they measured it. Like, they used a survey. They used a survey to decide the DNA, but they're not telling me if they're looking at all of those genes to calculate. That feels suspicious. I don't really buy that. At least they have the environmental thing in there. Average likelihood of remembering dreams, likelihood to take naps. These are both odd things to think that your DNA. I need papers. I will look at papers. Nutrients, I'm marked as average for everything, so I'm gonna skip over it. My immediate gut reaction is there probably is some valid science on this one that is citable. Fitness. That's awesome. Okay, so I am similar to elite endurance athletes with a quicker heart rate recovery, with muscles that tire at an average rate, have the sprinter gene, and have an above average ability to raise maximum oxygen use. So basically, I'm reading that I am a born athlete and I should really be using my skills for good, because holy shit, that's that immediately looks like the best of everything, and I love that for me. I hope it's real. Okay, so depends on much more than your DNA. Dang it. Exercise can benefit endurance, but not all exercise is created equal. Yep. Science. Okay, so here we go. This is stuff that makes it seem more legit. For this test, we looked at DNA in 3 places. So they're actually referencing particular genes and explaining the function of the genes that we understand now. Nice. Explain some unknown factors. See, this one feels potentially legit. First is an article by the American Heart Association, which is cool, but that's not actually a research paper. Let's see if they have any. Okay, they are citing actual scientific literature. Who knows if it's actually legit. I'm not going to click on any of the papers yet, but I want to believe this. I want to believe that I could be an endurance athlete. Not to toot my own horn, but I do tend to I'm curious about the sprinter gene. I do tend to be a pretty physically fit person. I am a little out of shape for me right now, but I am, I usually pick up fitness really quick. I build muscle really fast. Physical fitness is something that's always come pretty easy to me. So I wouldn't be surprised if you could find some of that, some of that could be explained by genetics. I'm also constantly injured and don't recover from injuries super well, which would be fun to explain via genetics. Can you fix that? But yeah. Okay, this one is a single gene. So who knows? They looked at a marker, actin 3, which is known as the sprinter gene. There's a lot of unknowns. There's at least 200 that influence athletic performance, and there's likely more for sure, dude. Oh, and this one has more questiony things. Oh, okay, this is explaining the gene. Okay, it's called an additive trait. This means if you get a copy of this variant from both your mom and your dad, you're more likely to be fleet-footed than if you got it from just one parent or don't get the copy at all. Interesting. Those are science, man. Okay, so fitnessy ones, nutrients ones, sensory. Ooh, alcohol flush. Yes. Okay. And then tolerating dairy. These 2 for sure. I know of genes that influence this. I'll click on alcohol flush because this one's legit, I imagine. Unless they're doing something really weird, you can totally tell. Oh, they have a little graphic of it actually. Nice. Okay. So basically, alcohol flush happens, like the science of it, I'm going to like biology out real quick, happens because when you consume alcohol, the way your body processes it is that it breaks it down into this like toxic intermediate. I believe it's either acetaldehyde or acid, one of these. And so basically you have alcohol, it gets broken down into this toxic intermediate, and you need this enzyme, aldehyde dehydrogenase. Yeah, so it's acetaldehyde. Aldehyde dehydrogenase to break down that enzyme into something that can get flushed through your system. So you get ethanol is your first bet, alcohol. Acetaldehyde is your intermediate, this is toxic. And then you have this other enzyme that would be like right here on an arrow that turns it into this acid that can then get like removed from your system. If you're missing the enzyme that does this step, you get a buildup of this, and that will cause you to flush because it's basically like you're building up toxic substance in your system. This is common with people of certain ethnicities. Like it's common to be missing this, the genes that code for this enzyme or having a functional copy of that. But also, there are blockers for this enzyme as well that are like sometimes not a great idea to use, but can be used when people are struggling with alcohol dependence, because it will basically cause you to get like an immediate hangover. People that are missing this enzyme or have this enzyme blocked will get that flush, but can also get really like sick because of consuming alcohol. So if you're missing this enzyme or if you're blocking this enzyme, you got to be really careful with your consumption of alcohol, because this can be very, like a buildup of this in your system is really harmful. All of that to say, nerded out really quick, that this is something which is very well characterized, known to be related to your DNA, and is something I learned about in my college classes, like a couple different college classes, actually. And so my results suggest that my face is unlikely to flush after drinking alcohol. And it's because they're citing this particular reference. I do tend to flush, but it's because I'm very pale and I get warm. And if I get warm, I get red. It's immediate. But yeah, basically they're explaining alcohol flush is caused by the genetic difference that makes it harder for your body to do that. Yes, accurate. Based on the information I have. And that, yes, 35% of East Asians, mostly from these countries, experience that because of that genetic marker. And so they've got this, and then they found the specific gene which impacts the, yes. I'm going to finish a sentence. Yes, they looked at the actual gene which codes for that enzyme. So great. Great. Science, legit. That one, off the cuff, gets an immediate stamp of approval. That is legit. Don't know for sure about any of these other ones. But yeah, and so basically the same thing is true of tolerating dairy. Most people know this one, but there's an enzyme in your body that it can break down lactose, or you lack that enzyme. Most people that can tolerate dairy are from Europe, or have a lot of European DNA. For lack of a better word. Yes, so that. The caffeine intake one feels wrong because I drink an obscene amount of coffee, but sure. Interesting. This one is, okay, appearance. This is also going to influence how much I think that their science is legit, because you can pretty quickly check. So let's see. Okay. Average sized as a newborn, to my knowledge, yes. No cleft chin. Accurate. Unattached earlobes. Also accurate. I don't know how to move my earlobes are not attached. Genes for thicker facial hair. Sure. Blue eyes. Okay, I actually don't know. They're like blue, green. Sure, I will give it to them. My eyes appear bluish. Wet earwax. I'm not going to stick my finger in my ear to confirm, but I'll believe them. Ring finger longer than index finger. True. So this finger is longer than this one. It's not by like a lot, but it is by a lot on this hand. Ooh, jeez. Yes, accurate. Have freckles, indeed. I live in Seattle, so you probably can't see them right now because they hide. Brown hair that could pass as red. That is firmly wrong. Yeah. This isn't dyed. This is my hair. Average hair thickness. Average to thick. I won't fight on that one. Straight hair. It's more wavy, but it seems straight sometimes, so sure. I'm not gonna stare at my eyes more. Male hair loss. Lower chances. Cool. Skin pigmentation. Light to medium skin tone. I guess I'm curious how they distinguished them because my skin is like extremely pale. So it feels like that should have been like lacks melanin almost entirely. Feels like what it should have said, but cool. Likely no unibrow. I do not have a unibrow. Likely to develop all 4 wisdom teeth. I did, and I lost them all. I lost them all in a fire, you know, how you lose your wisdom teeth. No, I got them yanked. Cool. Well, that is fascinating. I am not really buying some of it. So I think immediate synopsis. Behavioral and personality feel like bullshit. I'll look into it. I'll check the science. I'll see if it actually is. But it feels like probably just not legit at all. Nutrients, I didn't look at them here, but I feel like maybe, potentially. I'm flagging the vitamin D one because I am definitely deficient in vitamin D, but I think that's because of where I live and not necessarily because of my genes. Fitness, I love that. I hope it's accurate. Feels exciting. Sensory, sure. Appearance should be legit. This brown hair one is like not right at all, so that makes me a little confused about the other ones. I would like to know more about like how they're assessing all of these, but otherwise pretty interesting. Didn't feel like they went too crazy. When I initially saw this on someone else's video, it seemed like there was a lot of like personality trait ones that were just like absolute bullshit. Like there's no way you can measure that. This feels a little less like reading your horoscope. So maybe we'll see. It looks like they do cite papers that they use and have a little bit more information about each. So I will spend some time on this, not sharing my screen or following my camera, and we'll see if this is legit, if all of these are backed by science, if some is, some's not, or if it's all bullshit and they don't actually support any of their claims with evidence. But yeah, I'm gonna end this bit and we'll get back to it later. I'm back. Also, warning, I don't know if I can talk about science and be entertaining at the same time, so we're gonna try, but you've been warned. For this part of the video, I'm going to try to avoid inserting my opinions too much and just focus on giving you the information that was presented to me on the website. I'm also going to be assuming that people aren't super familiar with all of like the details of genetics testing and predictive models and stuff, so I'm going to try to explain as much as necessary to keep people following and not get like too in the weeds. To keep this section as coherent as possible and avoid the rambling that I am prone to do, I am going to base this section around a few main questions. Question 1, what is the claim or claims that Ancestry is making regarding the traits section? Question 2, how are they backing up that claim? 3, are there any additional claims being made for this product? And 4, general comments. It's not a question. I just wanted to keep doing numbers. At the time of working on this video, there are 43 traits in 5 different categories available on the website. For the sake of brevity in the video, I'm not going to talk about each trait individually, but talk holistically about the approaches that they used and maybe provide some examples as appropriate in this section. But don't expect a deep dive on each of them. It would take literal years. I want to finish the video at some point. So first, what is the primary claim that Ancestry makes? So the claim here kind of comes in 2 parts. First, DNA somehow influences the traits that are available in this section. And secondly, that they have data to support how the genotype impacts the phenotype. And so question 2, how are they backing it up? This is going to be kind of the beefiest part of the science section, probably. Now that we're clear on what the claims are, let's get clear on how they back those claims up. There are a number of references available for each individual trait along the website on their specific pages, some traits having more references than others, but the primary reference used for everything in this section of the website is a white paper made by the scientists at Ancestry. Since this is the primary reference for everything and talks about the methods used for making the models and things, I'm going to spend a fair amount of time on it and want to dive a little bit more into what a white paper is here. So, one big difference between a white paper and a research paper is that a white paper is persuasive. Research papers aim to test a hypothesis and find out whether it's true or not, but aren't necessarily trying to persuade you of anything. White papers are essentially marketing documents created as product information to persuade you to purchase a product. Since it is a marketing tool and persuasive, I think it's important to keep that in mind as we look at this reference. Another major thing to be aware of is that a research paper that is published is peer-reviewed by experts that are meant to be unbiased. That is not something that holds true for white papers. There is no requirement that a white paper is reviewed by experts. They are still intended to provide factual evidence, but are different to peer-reviewed research papers, which are the gold standard in scientific research. Now that we're clear on that, let's dive into how each of those claims is being supported. The primary claim that DNA influences the traits listed in this section is supported by some external research. The robustness of the external research varies a little bit depending on the traits. There's definitely some more for some than others. For example, one of the traits, liking to dance, has a single reference on it, which the reference is a research paper published in Developmental Science that explores an infant's natural rate of rhythmic movement. The paper didn't explore the relationship between genes and the enjoyment of dancing, but instead, like, the rhythm of infants. It's not crazy to make a logical leap that something you're seeing in infants is likely related to genes, but it is a leap to then say that rhythm is related to the enjoyment of dance. And there is no cited connection for that. On another trait, alcohol flush, there are 6 research papers referenced discussing alcohol and flushing generally. One of those papers specifically discusses a known mechanism in the body that contributes to alcohol flush and identifies a specific gene associated with the trait. You may have heard my mini lecture on this a little bit earlier in the video. In that case, the reference provides more clear evidence connecting DNA to that trait in a very clear and concise way. So basically, the link between DNA and traits varies a lot depending on which one we're looking at. In some cases, by a lot. The second claim that they have evidence to support how the DNA is linked to traits is done by prediction models created by people that work at Ancestry. The first model of 2 is based on genetic variants found in literature, and the second is based on what is called genetic trait association analyses conducted by the scientists at Ancestry. Basically, both of them are leveraging information they have access to in order to find trends and try to create some fancy prediction models with some stats. I should preface, I work very closely with people that use predictive models and I am familiar with them, but by no means am I an expert on how predictive models work. We're going to be operating with a beginner to very low intermediate level of understanding, so you've been warned. Also, because I am not an expert and I love a good metaphor, I'm going to be using an example to help carry us through this section for a bit. Let's say we're trying to predict how much someone likes spicy food based on all of the food they have available in their home. And let's also pretend for this example that people always have the same amount of food between individuals, and also that you have a consistent list of groceries in your home at all times. Here, the list of food in your house acts as DNA, and your liking of spicy food acts as the trait, which I think is actually a trait on Ancestry. The first version of the model uses genetic variants known to be related to the trait of interest. So in the pantry example, we know that there are certain foods that are related to people that like spicy food or not. Think hot sauce. And so rather than trying to look at everything there, we would be looking specifically for those items we know to be linked to the trait. The second version of the model uses survey results from the consumers of Ancestry to try to find those links between the trait and the DNA. In this case, instead of having the previous information about what items might be associated with people that like spice, we need to find that information. We would survey a group of people to see if they liked spice or not, and then try to find patterns in the pantries of the people that liked spicy food versus those that didn't. And then hopefully that would tell us more about what items are associated with the love of spice and what might indicate people don't like spice. And then we use that to predict people who haven't been surveyed. This flow diagram shows the general method used to make that second model. They start with all of the DNA and survey questions. They then decide what trait they want to figure out. A smaller sample of the population, about a third of the starting number, is pulled into a training data set, which is used to start trying to find patterns via a thing called GWAS. Don't worry about the specifics. We'll talk about it. Then they take another third-ish of that first population to make a validation set that they use to create a calculation that helps guess the likelihood that someone has a trait, the PRS score. They finally fit the model and use that last bit of the population to test what they've made and assess the strength of the predictive power. Given the importance of predictive models and that it's the start of this process, let's get into it a little bit more. The first input is self-reported survey results. For Ancestry, it seems that the surveys were mostly single question based on what is available for me to see. When I went to the DNA survey part of Ancestry, where I believe the survey questions are housed, the first question I was asked under personality was, are you more of an introvert or an extrovert? With 4 available answers: extrovert, introvert, equal parts both, or I don't know. A question under the drive section asked me to rate on a scale how optimistic I am. There was even a lifestyle question that asked me to multi-select how I get the news. That one was weird. The number of respondents varied per question. I found some ranging from as low as about 100,000 respondents to up to 750,000 respondents. Within the paper, they had an example to discuss the model. So here is the general split of the sample population. They got about 650,000 participants. A majority of the population of the survey answered yes. There was a larger number of women overall, and people of European descent was much larger than the rest of the groups. The age group didn't have a notable skew, but it did have fewer responses for the 75 to 90 age groups and the 90 plus age range. The second input to the model is DNA. This is the DNA sample submitted by customers and processed through a third-party lab. The method of sequencing here is called autosomal genetic testing, which surveys about 1% of the genome. This targets specific regions of interest. Just a note here, depending on the specific lab doing the testing and the notes from the customer, the specific regions will be different here. So 23andMe and Ancestry likely are surveying different parts of the genome. Back to the food spicy example, this would be similar to using a single shelf in your fridge as your survey, rather than all of the food available in your house. It might get you what you're looking for, but there's a chance you miss something of interest. Now that we've talked about the inputs for the model, let's talk about how they found the genes for the traits. GWAS, gene-wide association testing, is a method that you can use to test the significance of a trait against a gene. They show the output in figure 6 on this paper. Basically, to read this, each dot on the graph represents a gene tested, and the height of it on the graph indicates the significance of that gene for the trait of interest. So the higher the dots are, the more significant. The big blocks at the bottom that look like just color blocks are actually just really big clusters of data. So it's like a lot of insignificant data points, insignificant genes. Anything above the red line here should be noted as significant. So there's a lot of significant genes. Once they've got the genes figured out, they calculate a polygenic risk score. It's too much math. I'm not going to dive into it. But I'll flash the formula on the screen somewhere in case you want to see what it looks like. This is basically the math that gives us a probability score that someone has a trait. And finally, we have the model. We can see how good it is. There's a few graphs that kind of show the significance or like the how good the model is. But I'm going to show figure 10. I think it's the easiest one to read and the one that I see most presented when people are like reviewing these types of models. This graph shows the true positive on the y-axis and the false positive on the x-axis to assess how strong the model is. The dotted diagonal line would represent a completely random model. So if it falls on that line, it's useless. It doesn't help us at all. And a perfect model would go straight up at the start and be totally flat at the top to show that there are no false positives. I'll flash on the screen a nice visual of one that I think shows like a good example of how to read these. This model doesn't show 100% accuracy, which they don't claim, but it shows a very slight predictive power in that it's not completely random. That's ultimately what's used to call this trait. And that's it. That's how Ancestry supports their claim that they have the knowledge of how to relate genes to traits. So we've covered the main claims. What other claims is Ancestry making? One other claim that they make, but isn't necessarily like the bulk of this, is that they can assess how heritable a trait is. At the bottom of each individual trait, there's an estimated percent that shows how much is genetic versus how much is environmental. This is part of the data they generate when making their predictive models, so I'm not going to spend time talking about it here. The math for the individual traits, from what I can tell, isn't publicly available, so I have no information on what the summary data looks like for anything, except what was in the paper, which is probably out of date. The last claim I want to highlight, though I'm sure there's more that I'm missing, is that the number of responses to the surveys makes the data more reliable. This was shown in the Taking Naps page specifically, but may have been in more spots that I missed. Wrapping up the science bit before we move on. If you're still here, geez, you deserve a medal. Since I opted to make this video unreasonably long, too many things, I thought I'd add some notes here before I go into the other thoughts so I don't forget science. First, predictive models are a great and powerful tool that can be really helpful. The use case I'm aware of most is relating genes to diseases to help with diagnostic modeling, but there's other uses. That being said, predictive models can be incredibly tough to build and work with and are really complicated. It can be challenging to build a model that shows significance. As I said before, Ancestry isn't using all of the genes. It's not whole genome sequencing here, so they're using a very small percentage of the genome to make their assessments. This is common practice in this type of gene assessment, but it's something to be aware of, that we may be missing data that is valuable in these cases. Another thing that I want to talk about is that using self-reported survey results as a major input to things it's tricky. This type of data is very tricky to gather well and to leverage appropriately. It's really prone to bias for a lot of reasons, and for a decent number of traits, this surveys probably didn't provide the best data set to work with. And another major note, while the sample numbers do appear high, and they did kind of account for a skewed population in the final math they used for the model, the samples are just much smaller than Earth's population. Within the paper as well, the skewed racial data likely also limits the real power of the model they built, assuming they haven't been able to get more information from the undersampled populations. I'm specifically looking at the very undersampled Asian population in this paper. It's been found with predictive models that if you have a really skewed population, those models will underperform in a significant way on those populations. So while some of these models might perform okay for me, a person of European descent who is a woman, the most sampled population here, it may perform really poorly on other people. To note, for the trait section, it's like not a big deal if they give you a wrong assessment on if you're an introvert or an extrovert, but it's definitely something to be aware of if you're doing something like diagnostic modeling. Basically, my main takeaway is that predictive models are only as good as the input you put into the model, and I'm not like totally bought into the fact that the input here is great. I'm not personally convinced that the data here is strong enough to make any real claims about the traits they're talking about. To say something nice, I do really like the phrasing they used to make some of the calls. Rather than having a direct, this is true claim, that each trait is given a description that you're likely or not to have that trait. They also make it clear that both the environment and genes play a role in the traits, which is just like pretty obvious. It's a good thing to emphasize though. Also, while I say it's a good note from a science perspective, it's probably a good note from a marketing perspective because some of those traits they called wrong, like super wrong. Brown hair that could pass as red. That is firmly wrong. I'll have a more robust conclusion at the end and some more thorough opinions. But now, let's get on to ethics. The ethics of direct-to-consumer genetic testing. As expected, the research part of this video took forever, so I'm going to be brief going forward. I'm sure I could talk forever about the discussions around the ethics of direct-to-consumer genetic testing and even like the crimes that have been solved with it. So if you're interested, let me know. I can talk about it more later, but not right now, not in this video. In an effort to not make a 5-hour video, I'm going to skip the deep dive for today. Right now, I'll highlight some of the major discussion points that I have heard around the ethics of testing, as well as some of the major things I found when I was researching for this video. Most of these revolve around concerns related to using these types of tests for health-related data points. So not like people caring about whether or not they claim you like spicy food, but whether or not they claim you have a gene that might code for cancer. Which, at the moment, I should note, I didn't see a ton from Ancestry that fell into this category. First, I found a great article from bmj.com that highlighted some of the major ethical concerns around using these types of services for health indications. These calls may have clinical implications, but don't necessarily have the same scrutiny over them as FDA-approved clinical diagnostic tests. Without being very thoughtful about how we put these tests out and market them to consumers, they can be harmful in one of two ways, according to this article. The first potential harm is that it can make someone feel a false sense of security by thinking they're negative for a marker when the test just didn't capture all of the variants. This is one to be aware of for the BRCA gene, which is tested by 23andMe. They're testing for 44 variants out of, I believe, hundreds. And so you may get a false positive within that test, but actually be a carrier for that gene that would be captured in a different test. While it might not be a big deal in some cases, this could potentially cause someone to wait much longer to work with a medical professional to assess risk and might actually increase the risk of someone developing a disease in some cases. Another harm, which you can debate if it's more or less than the other, is that false positives are pretty common in this type of test based on how they're provided and can lead to an unnecessary level of anxiety for the people that receive those positives. They might even seek medical intervention in the cases that they do get a positive test. An example in this article was someone testing positive for the BRCA gene and scheduling a surgery consultation before realizing that they actually didn't have that gene. Ultimately, in that case, they actually were able to cancel the surgery, but you can imagine a scenario where someone completes an unnecessary surgery for a bad test. More broadly, something I personally didn't consider is that people might not actually think that they're going to receive that type of information when doing these tests. Sometimes you just, for funsies, toss off the test to see what traits you have or where your genes might be from, and then come back with a health indication that you should receive clinical help with. Typically, best practice in medicine is to provide necessary information before you conduct tests, and you work with the patients to help them figure out what to do in the case of a bad result. There's a preparation period that is intended to help people feel better, manage information which can be scary. These tests don't provide 100% certainty of anything, but receiving a certain result might cause someone a serious amount of distress. And in the case of these tests, there's no immediate opportunity to talk to a healthcare professional about what that might mean and what reasonable steps might look like after you've received that result. While we don't have a strong data set to understand what the reality of that might look like and how much harm could actually be imposed, it's an ethical concern that's been raised and I think we should be aware of. This isn't something we're really seeing Ancestry specifically do yet, but it looks like they might be trying to start to gather that type of data based on what I could see in their survey results, and I hope they consider this. And it is something that 23andMe actively does. Another potential ethical and privacy concern around this type of thing is that companies like this aren't regulated under HIPAA. While individuals and general public might think of this as health information, it's not technically categorized as that. This means that there aren't legal requirements holding these companies accountable to the same standards for the types of tests you would receive in a medical setting. I've been very doom and gloom about the ethics of this because there's implications and we should be concerned about them. But one thing on the positive end for this type of testing is that it can make this type of information more accessible to people. Genetic testing in a clinical setting is expensive. It's hard to get. You might be geographically limited in being able to get it. And having direct-to-consumer genetic testing available can make that something that is available to more people who might not otherwise have that. So between regulation and consumer experience, there's some notable ethical considerations to be aware of. And there are likely many others, both in favor of and against, considering moving forward with these types of services that I did not capture here for brevity. We are brief in this section. Consumer thoughts. Let's get it going. To get access to everything on Ancestry, it's about $100. And to get access to the additional trait section, you're going to toss an extra like $10 to $20 on there. Even having paid for this service, I keep getting pop-ups for the subscription. I'm not really sure what the subscription service is about, because the traits will still update over time, like your geographical results as well as your specific traits. But yeah, I don't know. There's a subscription. I didn't look into it. I think I should note, I am not the target demographic for this type of service. I think if you're someone that has a decent income and is like very into genealogy, there can be some pros to this if you like that. If I wasn't doing a video for it, I wouldn't buy it. I don't think I can justify spending that amount of money on something I looked at like twice maybe before I actually decided I wanted to do a video on it. Yeah, I don't know. I'd probably save my money and go for a horoscope instead. Conclusion and final thoughts. I'll be nice and start with the things I like. Ancestry does a pretty good job of making science information accessible. They have a learning hub, which has information about DNA, genetic testing, and all sorts of stuff. And from what I can tell, it's pretty accurate and like really accessible. You don't have to have a strong background to understand it. And I think that's great. Science is cool and people should know more about it. Also, I'm certain I forgot to mention this, but my traits changed from when I initially started filming this to more recently. I started filming this in April of 2023. Yeah, that was like 1,000 years ago. And now it's October. And between those times, some of my traits had changed like pretty drastically. And while as a consumer, I think that might be like a little bit weird to see, as a scientist, I love that. I think it shows that they are continuing to do work and gather data and update their findings, which is great scientific practice. We rarely have all the information we need up front to do stuff, and so it's good to see that they're continuing to challenge their assumptions and build information. Now on to my less positive thoughts. To be like totally frank, I'm not a fan of this type of service. Which I'm sure you had no idea about until this point. And this is in general, this isn't related to Ancestry specifically, so I'm not trying to call them out. My primary issue with this, and I'm sure you could guess, is that I'm nervous about this type of service being available to the public without additional scrutiny. Honestly, I just have a bone to pick with products that claim to be science-backed and aren't. Not that it's like entirely bullshit, but this doesn't seem like the type of product that has undergone enough scientific scrutiny for me to feel comfortable with the claim that it is science in its marketing. I have a lot of issue with other random products that do the same thing. Claiming something is backed in science and fact when it hasn't undergone the appropriate level of scrutiny feels morally wrong to me. It hurts the public's perception of science, and it can cause people to buy shit that they don't need for like reasons that aren't real, for lies. While I think it's great that they're citing their references and they made their white paper available for people, I feel like it's giving off this impression that it's more data-driven and legit than I personally believe that it is. A standard customer isn't going to be diving into the data in the white paper and looking at all of their cited sources. They're going to see that there's a ton of references and that there's figures and stuff and think like, that seems legit. I only did this because I wanted to talk about it in a video, and like literally my job is research. So what would someone that doesn't do this type of thing for a living do on average? Probably not what I did. I wouldn't even do what I did. Right now, a lot of the traits are just fun, and there's not a real implication on people's health or life, at least for Ancestry. But they may, in the very near future, start to venture toward making claims about health that could have really serious consequences for people, and I think deserve scrutiny. The FDA is starting to pay attention to these types of tests, which is great. Another service, 23andMe, has received FDA clearance for some of its health-related tests. I repeat, some, not all, without being very thoughtful about how this information is made available to people, this could have serious effects on people's lives. That example where someone maybe would have gotten a surgery based on a test that was a false positive here feels like something to really think about before we make these like a standard that we use. And I haven't even started to talk about like the concerns around genetic discrimination or data privacy in real depth. This is a huge topic overall, and really, I probably barely scratched the surface of everything we could talk about. My main takeaway is that I wouldn't recommend this service, and if you're someone that's really interested in it, like, do your research and make sure you feel comfortable with the potential implications before you send your DNA off to some private company. I hope this was interesting to you and not like too much of a bummer. I left it on quite the bummer of a note. I'll probably be back with a completely different type of video, but if you enjoyed it, be sure to like it, and maybe I'll make another one like this in the future. Probably need a nap first, because I'm so tired. This has been a long video. Thanks for sticking around. I have no idea how you made it this far, but I hope you have a great like day and week, month, whatever the time is between now and the next one. Glad you were here. Hope it was fun. See you in the next one. Bye. Am I almost done? I've had a long day and my neck hurts. Oh, okay. Been here so long. Can you tell I've been working on this video for my entire life at this point? And yeah, cool. Okay, that's getting cut. It's between you and me. Honestly, don't even need to cut it. Nobody watches my videos. I've lost my mind. Okay, how much time?